right. Where am I at? Right here. Okay. So the course changes, and these do benefit students, in my opinion anyway. But if you don't think they benefit, then you can go the traditional route of what I was anticipating the class to be. But the dean did say that I do not have to give a midterm and final. It's completely optional. It's completely up to me whether you take one or not. Originally, it said that you had to in the syllabus. So this is the change for the syllabus. It is optional. So if you want to take it, you can. Nothing's changed if you don't want it to. And you have to email me if you do actually want to take the midterm or the final. Okay. So if you think it's going to help your grade, then by all means do it. I am also allowed to do quiz retakes. So on 6/29, it says 9 a.m. and 11 a.m. You can retake quiz 1 and quiz 2. The reason I have just one time for those is because it takes forever to make these questions. Well, not forever, but it takes a little bit to make these questions sometimes. So I don't want to offer 3 different times. But if those times don't work, just email me and we'll work something out. Some people have already emailed me and just been like, oh, I can't make that time, or can you make this time, whatever, for retakes. Just email me and we'll figure that out. Again, I'm going to try to be as flexible as possible. Are there any questions on 1 and 2, or like how the final midterm thing works?
I had a question just overall. So like, say you take a quiz and you get a grade on that one, say it's like a B, then you retake it and then you get like a C on it. Which one of those, like, how are you?
The way I always do it is well, I always take the highest grade, to be honest with you. But what some students do, not you, but some students, I'll just do a retake, and then I end up grading the thing, and they fail it. Where the first time they might have gotten a B, so then they wasted my time because they didn't even bother studying. They're like, oh, maybe I'll get lucky, even though I didn't study at all. So they're wasting my time. So what I usually, but I mean that's like my high school students. Some of them just kind of take advantage of the retake. It's like, this is still my time too. Like, I'm not even supposed to offer retakes, but I'm doing that like to be nice. So as long as you don't take advantage of it, that's fine. I usually don't lower the grade just because that's stupid. ACT always takes the highest score. SAT, it takes the highest score. So why, if you get lower, I usually don't count that. But again, don't waste my time. Try to be respectful on that. And again, I'm not saying that you're going to do that, but just people have done that in the past. And other professors are like, why would you offer that? Students just take advantage. I'm like, not all of them. Like, you can't punish all of them because one is kind of waste my time. But no, I always take the highest, to answer your question.
Okay, thank you.
Mm-hmm. And then any other questions on 1 and 2?
So about the midterm and the final, we choose the day to take them, or you can?
Well, the midterm would be during the midterm week that was originally planned. So really, you would take the midterm next week. So like here, let me go back to the calendar really quick, because this will make more sense. So actually, I should have just shown this right away. All right, so if you go, okay, so we're right here. So we're going over 3 sections today. What is this? Oh, that's just like someone's doing a quiz makeup today. Here, like that's an example. Like, they just said, hey, can I just take it after that second class? I'm like, sure. That's an example. And then here's office hours for people. So next week, this would have been midterm week. I'll write that in there, midterm week. If you were actually taking it. Now, just know the midterm is all of this stuff. So it's going to be all the stuff from the first week, second week, and third week, all in one test. So it's probably like an hour-long test, if not longer. But you could make up quiz 2 here or quiz 1, and I just basically invite people to these sections if you actually are going to be taking that. But you would be taking the midterm here. Does that answer your question?
Wait, we're on the 23rd.
What's that?
What day is it? That's what makes sense.
Let's see here. I guess it would be Tuesday then. Yeah, I should get rid of this. It's freaking midterm week. Let's just say midterm. So if you were going to take it, it would be here. Yeah, it'd be the Monday. It'd probably be, or Tuesday, I'm sorry, but it'd probably have to be after this lesson. But just email me and then we'll figure out the time too. So if that doesn't work for you, we can figure out another time.
So you said next week, right?
But it would be next week, yeah, because it was originally I had it as 3 weeks and then a midterm and then 3 more weeks in the final. Here's another thing I had here was I don't know why I don't have makeup quiz 2. I allow a second makeup for quiz all the quizzes. So at the end, you can actually make up any of the quizzes that last week as kind of like a last ditch effort to do better. And again, I can be flexible with these times too. It's just easier if everyone meets at one time, because then I'm not bouncing around and making sure I'm home at a certain time or have internet connection at a certain time. Like that's why it's like I do want it separate days, but I know it doesn't always work for people. So
So
But yeah,
next
just-
week will we have quiz 3, or is next Monday just retakes?
so that's a good question. And if you look at the calendar, I moved quiz 3 to this day because what I did is I took 5, and I'm going to go over this in like a second, but 511, 512, and 514 we're going over today. And then I moved 513 to its own separate day because that is one of the hardest sections of the whole class. So now we have a whole day to work on it. And then you have the whole rest of the week. And then quiz 3 is going to have all this 5.1 stuff. So there is no quiz next week, but you can make up a quiz. So if you notice, there's no quizzes here. The quiz is right here for quiz 3, for the 6th. If you can even see that, I don't know. That 6 is kind of small.
Okay, cool. Thanks.
I'm sorry for all these changes too, because I'm not trying to be like confusing. It's just I'm trying to be flexible, which means things change. But if you don't like the change, again, you can just take the midterm, take the stuff that was already originally scheduled. It's just, to me, this benefits you because it spreads things out more. You have more time to learn it. It's not so much at once. So let's see here. Any other questions on the calendar? And I'll clean this up too as we get closer to it. And again, email me and we can figure out something to individualize, like individually help students out, like whatever you need, because everyone's different. Everyone has different needs. Everyone has different work schedules and yada, yada. So again, whatever you need, we'll figure it out. And this is also linked on the website. I don't know if people even use the calendar, but it's linked right here on the bottom of the Math 132. Remember, the one-stop shop, everything's here. And you can just click month, or I mean, you can do week if you want to, but like month, and then it has everything that I just was showing you. So it auto updates from this calendar to be here. So it should anyway. Yeah, it does. Okay. All right. Any other questions on 1 and 2 there? These two things, the quiz retake and the midterm. Okay, and then this is what I was just talking about. This week's live lessons will only cover these 3 sections. They are the easier sections. 513 was moved to next week, which means the quiz got moved a week further. So there is no quiz next week. But if you want to make up a quiz, you can. Okay. And then number 4, it says, since we got rid of the midterm and final, there is extra days we can use, so we will not have to meet twice a week. Okay, so let's go back to the calendar. And I made it because people were complaining about meeting twice a week because their other classes weren't supposedly meeting twice a week. I don't know what other professors are doing. But anyway, I made it so every Wednesday is an office hours. So if you need individualized help, you can get it rather than sitting and hearing me talk the whole time. So like this was all like jumbled up together. So I basically put all this in these were here originally. Okay, so I moved these because we have extra time now because we have this extra week at the bottom and then we have this midterm week. So now we have all this. This is the only thing we're going over. And then we have an office hours. If you're not understanding it, you can meet with me during office hours. And then we have a whole nother week quiz on just this rather than all this stuff. So it's just a quiz on 6.1 rather than 6.1 and 6.2. If this was over here, it would have been a bigger quiz. So everything's spread out there. And then we have a quiz on just these 2 sections. And then I just put the whole last section. There's like 9 subsections on this, but it's 6.3. That is going to be open note. We'll talk about that as we get closer to it. Because I made like a little like notes thing that's going to help for that. So that's basically going to be your last quiz, just that. And then you can still make up all these quizzes. I don't know why I don't have make up quiz 2 here. Oh, you know why? Because you make up quiz 2 here. That's why. You make up quiz 1 and 2 here. So this is just 3, 4, 5, and 6. Okay. Sorry, I think I was working late at night or something when I was making this. But either way, I'm flexible. We just have to figure it out. And again, just don't take advantage of my niceness in quotes. So any questions on the calendar or anything? Anything that I can change that would be better?
So office hours, do we have to like tell you that we're going to join, or do we just join?
Yeah, like this person in particular just said, can you meet at 10 to 10:30? So then I just made a calendar invited her, and then that way, and then there's like a Google Meet attached to it. So like say you wanted to meet tomorrow you can meet at the same time as her too. Like office hours can have multiple people, but like, so I would say office hours for whoever And then I would just do this, and then I would, type whatever their email is here, and then save it, and then it sends you the invite, and then you just accept it, and then you know what time to meet. And the link for the Google Meet is in there, so you'll be good to go. That's just like I live off my calendar. Like I would forget stuff if it wasn't in the calendar, so that's why I do that. And I do office hours on Sundays. Sometimes two people meet on Sundays. They want whatever you need. Usually these days are a little rough just because family stuff and whatever. So that's why usually the second half of the week I don't usually fill. But office hours aren't like a full lesson. It's not like you have to sit there for 2 hours. It's usually just clarifying. Like office hours aren't meant to replace this lesson that we're going to do, because obviously everyone would just want their own separate office hours rather than sitting hearing me talk for 2 hours. So. Any other questions on the calendar? Anything I can improve? Anything I can make it? Like I can't like get rid of these things. I have to teach this because it's the curriculum. But anything else with the scheduling, I can change. If you do come up with some, email me, whatever. We'll figure it out. And quizzes will still be on Monday, so that doesn't change. Since we got rid of the midterm. Yeah. Okay. So I went over everything. All right. Now we're starting the new unit. Okay. If you remember, the units don't really matter so much because we're doing quizzes. It's not like we're throwing everything together at once. But if you go to this website here, like Unit 2, there was no Unit 3 because Unit 3 was covered in Calc 1. I also got rid of some of the stuff that was covered in there. Unit 4, we only covered certain parts of Unit 4. Okay. If you actually went to what parts we skipped, it's stuff that you should have covered this in Calc 1, this differential equations. Now, if you didn't, that's fine, but it's Wabanzi. I'm not allowed to teach this because it's not on the curriculum for that. So that's why I skipped 4.2. If you're wondering why the numbers jump around, it doesn't really matter. The numbers are just so everyone's kind of, linked up with the same, like what we're doing. Okay, we're doing 411 today, so then everyone knows what 411 is. That's what the numbers are for. It's just so it's easier to organize. We're right here now. Okay, we are not doing 5.2, so you don't need to worry about that. Again, it's not in the curriculum, but we are doing these 4 sections. We're going to do 513 next week, like I said before. These 3 sections are all going to be just basically equations and doing stuff with integrals, because the whole thing is application of integration. The last section, it looks like there's a lot, but again, this is going to be open note, and I made this and I'm actually making it better. Where is it? Right. I'm making this, whoops, let's zoom out here. I'm making this flow chart where you can actually solve the problem using it's just a flow chart. Okay, does this work? No. Okay, go to the next one. It says true and false here. So it's going to tell you what to do. You just have to follow this. Usually in Calc 2, you would memorize this, which is just a nightmare, especially for an 8-week class. So I'm just going to actually give you this, but I'm making it better too. So it's actually going to be even more thorough for it. And then that's going to be the last quiz for that, that section. But yeah, let's do this. These sections aren't too bad. 513 again is the worst section, I would say. But yeah. But that's what this Unit 5 is all about. It's using integration for an application of something. Okay, like the first example for the application is the area between graphs. Okay, the next one is going to be arc length or average value. I'm sorry. The next one is volumes, and then the next one is arc length. So the last one was arc length. If you remember, integration helps with the area of any plane. So if you want to find the area of this weird non-basic shape, you can use integrals. Okay, and then it says right here, this area is based on the accumulation of infinitely many rectangles that have a width approaching 0. Okay, if you remember before in Unit 4, we talked about you can have infinitely many rectangles and it finds the area. Okay, and then it says right here, other calculations can be made using this accumulation that integration is based on. So we're going to, the fact that you can add up these rectangles to figure out infinitely thin, infinitely many rectangles, the fact that you can do that, it offers applications on other things so that we can use this fact on. And the first one is the area between graphs. So this is just the area under a graph. So here's f of x, the area underneath. But what about the area between? Okay, so you see this picture right here. We have y equals f of x and y equals g of x, and I just want to find the area between them. Okay. The equation you would use is you would subtract off whatever one's on top. Okay. Or really whichever one's furthest from the x-axis, which is f of x, minus the one that's on the bottom. Okay. So this is the equation that we're going to be using today. Again, this is just a sneak preview. I'm not expecting you to learn all this. Don't write this down because we're going to be going in depth on this in about 1 second after I do the sneak preview. So that's basically the first step. You're just subtracting. So you're doing the integrals like normal, but you're just subtracting the one that's on the bottom. Okay. The second one, average value of a function. So say we have a function right here in purple. Let's just say this purple is f of x. Okay. And you can imagine there's a bunch of y values here. So like there's a value here, 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 here. The highest y value is there. The lowest one's here. If you added up all of these y values and averaged them out, you would get this f average. Okay, so the way I think of it, and I'm going to explain this in a little bit more detail too, but imagine that there's a bunch of infinitely thin rectangles that are underneath this graph. Okay, infinitely many, just act like it's infinitely many people, and it's like a lineup. So you have a bunch of people standing shoulder to shoulder here. If you added up all their heights and divided by how many there are, you would get this equation. Okay, if you have no idea what I'm saying, don't worry about it. You can just use this equation and you'll figure out the average value. Okay, and yeah. We'll go in more detail in a little bit. 513, we are skipping for this week, and I'll show you why. It's just very complicated because now we're actually, instead of finding the areas, we're rotating it around an axis to form a volume. Like this one's rotating around the x-axis, this one's rotating around the y-axis. And you can find the volume of a weird shape. So if you remember before, we had an area of a weird shape. Now you can find the volume of a weird shape. So now you're going 3 dimensions. Again, we're not worried about this today. Another area, volume application is, if you can imagine, this is the x or the y-axis right here. Here's the x-axis, and you can imagine making a bunch of shapes and lining them up, and then finding the volume of this weird shape that's formed. Okay, you can do triangles, you can do squares, that sort of thing. Here's semicircles, so it looks like a dome, but you can find the volume of this weird shape. Like what would the name of this shape even be? You know, we're used to like pyramids and cubes for volume. This is like just a weird dome shaped, you know, I don't even know how to explain that. The only way to really explain it is using the equations. But anyway, you're adding up from A to B, you're adding up the areas of each of those individual cross sections, they're called. Now, if we were in class, we would actually be making these. Students usually think it's stupid to make these, but I just like the visual for it. But you can like make rectangles, and then here's y equals x squared, and like what would be the volume of this? What would be the volume of this if you do semicircles? Here's triangles, here's rectangles. But we're not going to waste time doing that. Well, we can't just because we're not in class. But students usually get annoyed because they have to cut pieces of paper, and they don't want to do that. But that's essentially what the volume you're finding. So you're making this weird shape based on y equals x squared or based on some other function, and you're adding up those areas to find the volume. But again, next week we're going to go over that. The last thing we're going to go over today, 514, is arc length. Okay, arc length, you're basically adding up the infinitesimally small distances between them. So say you had an arc length right here. Imagine you had a distance formula, and you're adding up infinitely tiny, infinitely many distances. So you have all these little tiny distances, and you're adding them up. Essentially, that's what this equation does. Okay, now if you're like, whoa, where'd this equation come from? I have the complete breakdown right here. So it says the sum of the distances, sigma means sum of the distances is equal to, this is just the distance formula. But then I made n go to infinity. So if you have n go to infinity, now you're using the integral. If you remember this from Calc 1, if you don't, that's okay. And then all these delta x's and delta y's become dy and dx. And then I divided by dx squared, and you end up with this equation right here. Now this equation is the most important thing. This derivation for it, where this comes from, not as important. But the main thing is you take the derivative, you square it, you add 1, you take the square root of it, then you do the antiderivative. Okay, we're going to go over many examples for this. It'll be fun. Okay, that's the last thing we're covering. So that's just a sneak preview. So we have arc length, area between, and average value. That's what we're going over today. And I want you to like imagine that in your head, like if this was like a course that you were running, the distance that you would run from here all the way through this curve would be the arc length. Okay, and again, you're just adding up individual little distances each time to get that. All right, let's actually do the problems because it's really hard to learn math just by hearing about the concepts. Well, for most people anyway. So let's go with, we're gonna do the practice final later. Let's go to the whiteboard. Hold on 1 second. What is it? Week 3. Okay. So we have all this right here. I already loaded up the final exam, the practice final over here, but we're going to ignore that for now. So I'm going to zoom in so we can get rid of all this clutter, and we're just going to focus on area between curves. So in your notes, I would write 511 area between curves. So we can get started on this. I'll explain where this formula comes from as well. All right, here we go. So you have this, I'm going to zoom into this picture here. So you have this picture right here, and say that I only wanted to find the area between. So I'm only finding this region that's colored in already, but I'm going to color it in again for some reason. Okay, essentially what you're doing here, let's do this color. All right, so essentially what you're doing is you're finding the area under F. So imagine this area right here. This is so bad. Let me use my pen here. So you're finding the area right here for all this. So that's the area of F. So that's this part right here, the area of F from A to B. You notice this is A to B. Okay, and then you're subtracting off this area on the bottom from G. So here's G right here. I'm subtracting off this area right here. That's this part right here from A to B again. The only thing that you're going to be left with is this area right here, which is, I guess, orange at this point. Okay, that's where this area between curves comes from. You always have to subtract the one that's furthest from this x-axis. So the one that's furthest from it, from A to B, is, here, let's get rid of that. The one that's furthest from it from A to B is F. Okay, here G is further from it, like at this point compared to this point, because this one's closer, but we're only worried about from A to B here. Okay, the one that's furthest from it goes first. Okay, if you switch the order of these, you're going to end up with a negative area. If that happens, just make it positive. I will still count it right. Because some students are like, how do I figure out which one's on top and which one's on the bottom? The answer is you graph it using your calculator. These are going to be all calculator problems, but you graph it with your calculator, you see which one's on top, and then you know which one to put first. But say you just didn't do that, you were being lazy, you forgot, whatever. If you switch the order of these, you get the exact same answer. It's just that you end up with a negative answer. So just make it positive at the end and we're good. Your answer should always be positive. I would write that down. Your answer for these should always be positive. You're going to lose you're going to get a lower grade just because you made it negative. So try not to do that. Okay. Any questions on where this formula comes from before we actually use it on a problem? Okay. So let's do it on this problem right here. Here's an example. You have y equals secant squared x and y equals sine x. And it says, what's the area between from 0 to pi over 4? Okay, first thing I'm going to do is graph this. If you can picture this in your head, great. Then by all means, then you don't need to worry about graphing it so much. I can't, so I'm going to graph it. Now, it's not in polar. So if you notice, I'm in polar still from the last lesson. So I'm going to change this to function. And then I'm going to graph both of those. So it's secant squared x. So that means it's going to be 1 over cosine squared x. That's secant squared x. And then I'm going to graph sine x. Okay. Don't hit graph yet, though. If you notice, we're going between 0 and pi over 4. So what I'm going to do, check this out. Hit window. And your x min should be 0. The minimum is 0 for x. And then your x max should be pi over 4. So once you change the x min and x max, I want you to hit zoom fit. Okay, so it's going to zoom 0 if you want to do the shortcut. Now, if you hit zoom fit, and if I'm going too fast, I'll redo what I just did. I'm sorry. But if you hit zoom fit, it fits it to the screen. It's thinking, but so now you can actually, it only looks at the interval that you're looking at, and it fits it to the screen perfectly. But now you can see which one's on top and which one's on the bottom. And if you're going, oh no, but which one's which? I don't know which one. Just hit trace. And then you see how it's on the blue one? The blue one is this one right here. If you press down, it goes to the red one, which is sine x. Okay. So now you know which one's on top and which one's on the bottom. Secant squared x is on the top. Okay. I'm going to go over this again. So first thing is I would put both of them in the equation, unless you can picture it in your head. Again, some people can do that because they memorize what the graphs look like, or I don't know, people just can do it sometimes. You have the two functions here, then go to window, change the window to 0 to whatever you're going to. Okay, in this case, it's 0 to pi over 4. Okay. And then hit zoom 0. Zoom 0 is your friend. And then it fits it to the screen. I just like fitting it to the screen. If you don't do it, it doesn't, I mean, it does matter because it looks weird. Here, I'll show you what happens if you don't do it. It's harder to tell like which one's the top function and which one's the bottom function sometimes. See, like you have this, like you don't know where the interval is because you have the negatives and now you have the positives, and it's just kind of a nightmare. It also takes forever. So now you have to know that you're supposed to go from 0 to pi over 4, which is like right here. So it basically zooms in on this section right here. So again, I would do it this way. Everyone's different. Whatever you want to do. Okay. So we know secant squared x is on the top. So I'm going to actually go back and start solving this by using this formula up here. All right, is everyone still on board the ship? Does everybody have any questions? All right, cool. All right, here we go. So this is going to be our F. This is going to be our G. Again, if you switch the order, just make sure you make it positive. Okay, so we're going to have the area between is equal to the integral from 0 to pi over 4. Okay, because that's given right here. We're going to go over an example where it's not given. You have to do a little extra step for that. All right, F is the secant squared x minus the G, which is sine x, dx. Okay. From here, you can throw it in your calculator, but you're not going to get the exact answer if you do that. I mean, I'll throw my calculator anyway for fun. So here we go. Let's do math 9. Math 9 brings you this integral thing. 0 to pi over 4. And then my y1 is my f, so I'm actually just going to put the y1 in there. You can rewrite it if you want, but I already have my y1 and taken into account in the calculator. So I'm just going to do, you can hit alpha trace and then just do the y1 right away. Minus the y2. Again, you can rewrite it if you want. I'm just going to do the easier route and put it in there. And then it's with respect to x. So you put an x in there, you hit enter, and you're going to get some weird number. Actually, you can probably remember what that number is, maybe, but it's just root 2 over 2. Okay, so we know the answer should be root 2 over 2. Now we have to show the work that gets to this answer. Okay, are there any questions right now? I haven't really done any calculus yet. I just did everything on my calculator. Okay, cool. All right, so let's do this. If you remember, you have to do the antiderivative and then plug in pi over 4 and plug in 0 and you subtract them. So first thing is we need to do the antiderivative. The antiderivative of secant squared x is tan x. Okay, it's one of the formulas you have to know. The derivative of tangent is secant squared, so you can just go backwards. The easiest way to do it. The derivative of sine, the antiderivative of sine x is negative cosine x, so that's going to be a positive. Okay, and then we're integrating it from 0 to pi over 4. Let's make this neater. There we go. All right, so again, you plug in pi over 4 in here. So you have tan of pi over 4. I'm just going to write it down. You don't have to. Most people just know what tan of pi over 4 is, and they don't write it down. That's fine. Plus cosine of pi over 4. Okay, so that's when you plug in the pi over 4. And then you subtract that off of when you plug in 0. So now it's the same exact thing, only you plug in 0. Again, you don't have to show all this work. If you want to just go to right to tan of pi over 4, you might know that it's equal to 1 already. Or if you don't know it's equal to 1, plug in your calculator. Look at that. Here we go. Tan of pi over 4. 1. Okay, but if you don't remember the unit circle, that's okay. Another thing is you can just ask me during a quiz. That's what some people do. So this is 1. Okay, this is root 2 over 2. That one you kind of have to know the unit circle for. You can put it in your calculator. But then you get that weird answer that we got before. That's still root 2 over 2. Root 2 over 2. Okay, minus tan of 0. Well, that's awesome. It's 0. So we're going to have 0. Plus cosine of 0 is 1. So you can put a 1 there. Okay, the 1s are going to cancel because it's 1 minus 1. So you're left with root 2 over 2, which is the answer we got originally, if you remember. So everything works out. All right, questions on that first example? Now, say you messed up the f and the g, you would have negative root 2 over 2. Just make it positive. Don't lose simple points like that. I don't do points. Don't lose a simple lower grade for that. Don't get a lower grade because of that. All right. If there is no questions, hold on. Let me make sure that no one just typed a chat in. Maybe they typed a chat question. Nope. Oh, we got more people now. That's cool. All right. All right. Onward. Whoops. Wrong one. What am I doing? Okay. This one is a little trickier. Not by much. You can't really make these problems too tricky because they're just finding the area. But it says, what is the area between this function and this function here? Okay, so now there's a trig and a algebraic function in the same problem. This is going to be crazy. Okay, and if you notice it, I do not tell you the interval. If you compare it to this original problem, I tell you the interval right here. Okay, here I don't. So that means that these actually intersect and form a shape, but you don't know where they intersect. Oh no, what am I going to do? Well, you graph it. Okay, same rules apply of what I was telling you before. You just have to graph it and figure out what that interval is. Okay, so that's what we're going to do now. We'll definitely need a calculator for this. All right, so we are going to graph 2 cosine x. That's embarrassing. Okay, 2 cosine x. Okay, and then x squared minus 1. Okay, now this one we have no idea what to do with the window. I don't know if it's from 0 to pi over 4. It's probably not. Actually, I know it's not because I made these problems. So I'm just going to do zoom 6. Zoom standard just fits it on the screen. So you have something like this. There's my 2 cosine x. And then here's my x squared minus 1. Okay. Now we're looking for the area between them. Well, there's only one part where it's between them, and that's this part right here. Okay. Let me paste this in here. So we are looking for this area right here. Come on, computer. This part right here. Okay. But we need to know what is this x value and what is this x value. You can't just eyeball it and go, oh, it looks like 1.3 and negative 1.3. You need to actually figure out what this x value is and what this x value is so that you know the interval. Okay. If you remember the area formula, we're going from A to B. You need to figure out what A and B are. Okay, so that's actually what we're going to do now. But first, is everyone still on board? Did everyone get this graph to look the way I have it? All right, I'm just going to assume that you did. Okay, so we need to figure out. So we need to figure out where this intersects right here. To do that, we're going to let our calculator do it. So you do second calc. Oh, here, let me show you something really quick before we do that. Let's get rid of all this. If you try to solve this by hand, it's literally impossible. So if you try to figure out where these intersect by setting them equal to each other, so that's what I'm going to do right here, you can't solve this. This is impossible to solve using algebra. The only way you can actually do it is having a calculator do it. Okay, but you can't isolate an x and have it say x equals. If you can, let me know, because then you're going to be famous for figuring something out in math that is impossible. But you can't actually solve that. The only way you can do this is with a calculator. So a calculator is needed here. Okay. And then we're going to have to round what these decimal places are, what the decimal places are for these intersections. But here we go. So let's go back to the graph. To figure out where they intersect, what you need to do is hit second, trace, and it brings you to this screen right here, and you're going to need this fifth choice, intersect. So I'm going to hit 5. Okay. Now it brings you to this screen right here, and it says first curve. We want the first curve to be the blue. You can change the first curve to red, but I wouldn't. Okay. And we want to find this intersection over here. So I'm going to move the cursor closer to that one. Okay. Now first curve, I want it to be the blue curve, which is this 2 cosine x. So I'm going to hit enter. Next, it says second curve. I want it to be the red. Okay. If you went back to the first curve, it makes no sense. The first curve and the second curve, you can't have them. They intersect everywhere. Then that doesn't make any sense. Like you can't intersect with itself. You need to go to the second curve. So make sure, and it automatically always brings you to the other graph anyway. Second curve, hit enter. Now it says guess. What you can let the calculator do is you can move this. Wherever you move this, it's going to find the closest intersection to it. I don't know why it uses the word guess, but we want to find this one on the left first. I always go left to right. So I'm going to move it closer to this one right here. If you moved it closer to this one, it would find this intersection. One thing you have to know about a calculator, it is actually not doing any math. It's just counting, and it counts way faster. So what it's doing is counting all these little bits here on the graph and seeing where the bits are equal. Okay. So you have to make sure you're closer to the bits that you want. We want these little bits right here that are intersection here, and then we're going to eventually do this one after. But anyway, at the guess, it's closer to it there. Hit enter, and then it finds that intersection point right there, -1.625424. Okay, so what I'm going to do is write that over here. It says calculator needed. So we need our x to be equal to -1.64554. I knew that was wrong. Okay, 546524. That's embarrassing. Okay, 24. Okay, so that's one of the intersection points. Where did my stuff go? Hold on. Hold on. Whatever. I'm not gonna be able to switch colors. There we go. All right, so that's the one intersection. Now, if you go back to the calculator, we need to find this other intersection. So we're going to repeat the exact same steps that we just did. Second, calc 5. So we want that fifth choice, intersect 5. Okay, first curve is blue. Okay, second curve is red. Okay, the guess, we want to guess over here. So I'm going to move this thing here. Okay, enter, and then it finds the intersection point. You probably could have guessed that it was the positive of the same value we just had. So positive, say something like that. Oh, this one actually gives us more values because it got rid of the negative sign. It can fit more on the screen. It doesn't matter. Fit as many decimal places as you can. Your number will be more exact. Okay. All right. Now I'm going to be a little lazy here, and I recommend you doing the same thing with this. Is I'm going to say this is our A, and then this is our B. So now we never have to rewrite all these numbers again. In the calculator we will, but we don't need to write it by hand anymore. So that's A and that's B. So now what we're going to do is we're going to find that area now that we know our A and B. So the area between is going to be from A to B. Again, I know what those values are because I wrote them right there, of the top. So we need this top function. Well, the top function is this one right here. This is our F. This is our G. Another way you can tell that is just by looking at the graph. The cosine is obviously the blue. The red is the x squared minus 1. So you can kind of tell which one's the top and which one's on the bottom. Okay, so then it's going to be 2 cosine x minus x squared minus 1. Make sure you have parentheses like that. Okay. Now, since you used a calculator to find these values, I am perfectly happy with you just using your calculator to find this whole thing right here. Okay, so if you want, you can just use your calculator. You don't have to do the antiderivatives and plug all those in. Again, you probably want to, hopefully you're listening right now. You don't have to do, if you use your calculator here, you don't have to use your calculator here. Or I'm sorry, you can use your calculator here. You could, if you want to, do the antiderivative plus x and like plug in a and b. But you're plugging in a and b from your calculator anyway for these values because you can't obviously do this by hand. You can't plug this a value in here. That'd be a nightmare. So rather than doing all this work, I'm just going to throw this whole thing in my calculator because it makes it a lot easier. Okay, so from here, I'm going to quit out of this, and I'm going to go math 9. Okay, and remember it was negative 1.264554. I did that again. That's embarrassing. 5424. 24. Okay, do the same thing up here, only with the positive. Okay, now the one that was on top was the cosine. I believe that was the first one we put in for the y1. Yeah, so that's our y1. So, oh man, hold on. This is really slow, sorry. Okay, and I'm going to hit alpha trace for the y1 minus alpha trace for the y2. And then I'm doing this with respect to x. Then you hit enter, and you get some crazy number. In this class, we always round to 3 decimal places. That's just always the rule, round to 3 decimal places. If you ever forget, just ask. So 4.995 is about what the area is. Let's do this. Okay. Okay, questions on anything I did there? Okay. Well, let's take a 5-minute break, and then we will go over average value of a function. I'm just going to be sitting here, so if you do have questions and you want individual help, by all means, ask me. You can also ask about your quizzes too, or just ask about anything. That's up to you. Just let me know.
I have a calculator question.
All right, let's do it. What's up?
When I was graphing it, one of them came out as a straight line, and I don't know what I did wrong.
Okay. Oh, actually, I think I might have figured it out. Hit mode. Are you in radians?
No.
That might be it. I don't really know if that's it though. So you'd have to try it.
Okay.
In calculus, you always have to be in radians because all the derivatives for
Mhm.
trig functions are based on radians. So if you don't do radians, then it won't work.
Okay, let's see.
Yeah. I hope that works. I don't know.
Yeah, it worked.
Cool.
Awesome.
Lucky guess. All right. Any other questions, let me know. I'm going to mute myself though. So. All right, I'll be right back. 1 minute. Okay, are there any other questions? Otherwise, we're going to get started on the next section then. All right. All right, let's party here. Okay. Okay, next thing is average value of a function. And the way this formula works, actually, I explained this formula with rectangles, so it might be a little bit easier. But again, you don't really need to know where the formula comes from. But oops, that's my alarm. Timer or whatever. But sometimes people want to know where things come from, so that's what I'm showing you here. This proof is using rectangles. So right here we have it says the average value, and it forms a rectangle here. So the area of this rectangle, so the rectangle here. Hold on 1 second. Try to draw this a little bit better. Let's do this. So the area of the rectangle would be here, here, whoops, here, and here. Okay. The distance on the bottom is just going to be b minus a. So that's the width. The height is whatever the average value is. So this is the average value. Okay. That's, yeah. So the average value, whatever it is, so this is the length times the width here. So it's the area of this part right here. Okay. That's, if we want that to be equal to the area of underneath the red, you just do the integral from a to b of that red function. Okay, but we only want the average value, so I'm going to divide the b minus a over, and you get the equation right here. That's essentially how that works. Again, you don't really need to know that. Let's make sure I'm not on mute. Oh, this is embarrassing. I'm not. Okay, just making sure. But that's where the equation comes from. Again, you don't need to worry about that. You need to know how to use it. So we need to know how to use this. You just take the integral like normal, and then you just divide it by b minus a. Okay, here's an example. These are not complicated at all. There's not really any tricks you can do for these, so it's nice. Okay, so it says, what is the average value of f? I should say y, because this is a y, but it doesn't matter. From this equation from 0 to 3. So if we were going to graph this, which you really don't have to graph this, but I'm just going to do it for fun. So it was negative, right? Yeah, negative x squared. Oops, that's embarrassing. Jeez. Over 2. These are all in just one function, so you never need a second function. And if we graph that, oh, it's negative. That's fun. Let's do this. I'm going to actually do the window. You don't have to do this again. You don't have to worry about the graph of this. But I just want it to fit to the screen. We're trying to find the average value of all these y's. So there's a bunch of y's. Here it's 0. Here it's, I don't know, it's -1 here, but there's infinitely many throughout here, but we want to find the average of this. So I'm going to do a screenshot this to kind of show you how this average value thing works. Okay, so let's do this one. All right, so you can imagine there's a person that's standing right here. Okay, and then there's another person here, and their heights are based on the graph. Okay, but there's infinitely many people. You have to imagine infinitely many people. If you were trying to find the average, you would add up all these people's heights and divide by how many people there are. Well, that's essentially what this is saying. add up the people's heights and divide how many people there are. Okay, so what you're doing here is you're going to add up all the people's heights as the area, because there's infinitely many people and they're infinitely thin. That's the full area. Act like this is a bunch of people standing shoulder to shoulder across here. And then we're going from 0 to 3, so you just subtract those two values out. Okay. Again, you don't need to know that, but just in case you care where it comes from. So the average value is going to be from 0 to 3 of that y function dx, and then you have to divide this all by 3 minus 0. Okay. That's literally all you do. Okay, this one you don't need a calculator for, so I would expect you to show all the work. So I'm going to pull out the negative 1/2 just because I like to do that. And then I'm also dividing by 3, which is the same as multiplying by 1/3. Okay, then I'm doing the integral from 0 to 3 of x squared dx. Okay, so I took out this negative 1/2 and I took out this 1/3 to put them right there. Okay, you don't have to do it that way. I just like to make it neat like that. Okay, the antiderivative of x to the third, x squared is x to the third over 3. And we're integrating it from 0 to 3. Okay, so this is going to be negative 1/18. When you plug in 3 in there, you get 3 to the third, which is 27. When you plug in 0, you get 0, so that's nice. Okay, these are both divisible, so you end up with negative 27 over 18, but both of these are divisible by, somebody have a question?
Yeah, where did you get the negative 118?
Oh, okay, so right here, negative 1/6 times 1/3.
Oh, okay. Gotcha.
Yeah.
Thank you.
Oh, yeah, no problem. Sorry, I went too fast. These are both divisible. I said 3, but these are actually divisible by 9 as well. So you end up with negative 3 and then divide that by 9 as well. Simplify the fraction. And you end up with negative 3 over 2. Now, you should have a negative value because if you look at the y values, they're all negative, right? These are all negative because the x-axis is up here. So you should have a negative average value just because all the heights are negative. And you know what? I actually did this completely wrong. This is actually wrong if you think about it. I colored in the wrong area. Really, it doesn't change the answer at all, but it's like a conceptual thing that I would want to change. Really, it should have been the heights here, which is different because this area here is not the same as the area over here. It doesn't matter. That doesn't change. That was just me trying to explain things. But either way, you need to know how to use the formula, and that's how you get it.
I have a question.
Yep.
In the green part, where did you get the 3 on the bottom from?
When you do the antiderivative of this part right here. So if you did the antiderivative of x squared, if you remember reverse power rule, you add 1 to the power and you divide by whatever that power is.
Oh, I see. Okay.
You don't need to worry about the plus c though, but that's where that 3 came from. Yeah, sorry, that was from Calc 1.
Okay, cool.
Yeah. Thank you for asking that, because I'm sure other people had that question. It's just good. Another thing I usually ask students too, but I keep forgetting this semester is what is the most, what do you think is the most confusing? Not the most confusing to you, but what's most confusing to other students? What would other students mess up on? Does anybody have any thoughts on what students would mess up on? One thing that a lot of people, well, go ahead. What's that?
Sometimes the algebra.
Yeah, the algebra, definitely the algebra. Another thing is people forget that dividing by b minus a. So they write it in the formula, but then they just forget about it like later on. That's one thing that people forget. Another thing people forget, plug it into their calculator. Let's plug this whole thing into our calculator. Here we go. Here we go. So math 9, we're going from 0 to 3 of negative x squared over 2 with respect to x. It entered. Oh, I didn't see. That's embarrassing. I forgot to divide by 3 minus 0. You don't need a minus 0. I'm just doing that for fun. There you go. I just said that. Okay, and if you want to get it to a fraction, math frac is your friend, -3/2. Oh, fun times. Questions on this problem? Okay, for this particular section, I only did one example, so I don't have any other examples here. And the reason for that is there is no tricks on this. Like, it's just going to be a different function and a different interval. We are going to do another example if you stick around for the practice final. So we have this one right here, 512. It's also 0 to 3. 3 is my favorite number, so you see that a lot. But if you notice for like the first section, it was tricky because you had to figure out what A and B are. That's why I gave you 2 examples. This one, it's kind of what you see is what you get. You got to practice those. There's still tons of practice problems on the website that I advise doing, but yeah, that's why there's only one example here. I'm not trying to be lazy. Okay, any questions on 512 before we go to 514? All right, let's go to 514. Okay, this is going to be easier to explain a little bit because I can draw on this, but the arc length, the idea behind calculating the arc length with a definite integral is you're just adding up all the little infinitesimally tiny distances along this. Okay, so you're summing up the distances. This means summing up the distances, and you're summing them up along this entire interval. That's what this is right here. It's change in y over change in x. If you remember the distance formula, again, you don't need to know this, but it's delta x quantity squared plus delta y quantity squared, and you're doing the square root of all this. Okay, that's why they have this here in this picture. Again, you don't need to worry about that. Here, you're summing up the distance, summing up, and then this is again the distance formula right here. If you notice, it's what I just wrote up here. Now, if you do it infinitely many distances that are infinitely thin, then you do the integral here. Now, if you have a dx and a dy here, what you can do is divide each of these by dx squared. And when you do that, you're factoring out a dx squared. It shows up right here. You don't need to worry about that, but I actually did make a video on the website if you care where this comes from. Just again, because I know some people really like to know where everything comes from. I was one of those kids. So there's an embarrassing video of me explaining that in there. There's also a video, whoops. Okay, that's good to know. I need to open that up for everyone to see. There's also a video of an example problem. I forgot to link it here on the bottom, but I will link that. Sorry about that. I will open that up too. For some reason, I made that locked. The other ones should be open though, the other sections. I'll fix that at the end. Okay, but anyway, the moral of the story is you need this. Okay, they use S for arc length. I use L because some books use L, some books use S. It doesn't really matter. Just make sure you know what you're doing. You'll see the answer key. I usually use L. I don't know why. I think because the book uses L, but it doesn't matter. Okay, so here's our first example that we're going to look at. It says y equals sine x from 0 to 2 pi. By the way, you're always going to be given the intervals on this, so it's really similar to average value, where they give you the interval each time. I need to figure these out. Okay, so we're saying what is the arc length, that's what the L is, from 0 to 2 pi. So let me go to my calculator real quick, just so we can kind of understand what we're looking for. So you have sine x, and your y1. Your window, change it to 0 to 2 pi. And then zoom 0 to zoom fit. Now imagine running along this. Okay, you're running along this. Whatever length or distance that you're running, that's what we're looking for. Okay? Now, if we were going to estimate this, what's a good estimation for this? If you just looked at this and go, oh, this distance is probably going to be what? We can definitely say for sure that it's greater than what? Does anybody know? It's going to be greater than a certain value.
2 pi.
2 pi, very good. I don't know who said that, but thank you. All right, so if you look at this right here is 2 pi. Okay, if you ran a straight line, that was your thinking, right, sir?
Yeah.
Okay, yeah, very good. Some students don't actually get that. From here to here, it's 2 pi, straight line. You're obviously going longer than this. Okay, if you were going from point A here to point B, you'd want to do a straight shot. Okay, if you were driving, you would want to drive straight there. Okay, you wouldn't want to go all the way around and all the way up here. So you know that your L should be greater than 2 pi. Okay, you don't really need to think of it that way, but I like to, just in case, because when I get my answer, I want to make sure it's greater than 2 pi. Because if it's less than 2 pi, then I don't know how that's possible. You'd have to like teleport or something to make it where you're going this longer distance, but somehow, actually, I don't even know how you do it. It's impossible. Okay, but straight ahead, it's 2 pi because we're going from 0 to 2 pi here. This whole length should be greater than that. Okay, so let's use the formula that we have right here. Okay, the main thing that you need to do, I would always find the derivative first. Okay, you can plug it in there but then you're writing all this like the integral from a to b and the square root a million times. It's better to just do the derivative first. Okay, so that's what we're gonna do. The derivative of y, this means derivative of y, is cosine x. Okay, then I also like to square it right away. So that way I'm just putting it in right away as cosine squared. Okay, so that's what I'm gonna do now. I'm gonna do, so the arc length is, going from 0 to 2 pi, and we're doing the square root of 1 plus cosine squared x with respect to x. And I'm just using the formula for this. Up here, I did my derivative and squared it, so I'm putting it in there. What some people do, what some books do, and this is a nightmare, I highly advise not doing this, but they'll actually like write it in. Don't write this down, but they'll write it in like this. They'll go, oh, the derivative of sine x like this, and then they square it. That's really sloppy. Sorry, I'm just trying to go fast here. Okay, so then you do this, and then they still have to do the derivative here. You see how they're writing the square, they're writing the square roots and everything multiple times. It's better to just do it once and then throw it in. Otherwise, this is like a nightmare. And that's just my opinion. Like, if you want to do it, if you're one of those people that likes that, then by all means. But I like to just do it all in one foul swoop. Okay, you should notice, hopefully, that you can't actually do this antiderivative. It's impossible. Okay, you have a function inside of a function. You can't use u substitution, which is usually what you would use if there's a function inside a function. So the only other option is a calculator. So moral of the story, a calculator is needed for many of these. Okay. It's also good practice to see, oh, I can't use my calculator. I can't use any integration technique, so I have to use my calculator. Okay. So let's go to our calculator then for this. Calculadora. All right, cancel out of all this. Okay, math 9, going from 0 to pi. And we're doing the square root of 1 plus cosine x squared. Let's check just to make sure. With respect to x. It's counting up all the little bits. Sometimes it takes a while. And then you have 7.640. So I want to round to 2 decimal places. And that's it. Did anyone else get that?
Yeah, it's good.
Yeah.
All right, cool. And that's it. And there is nothing you can do here. You can try to do some trig stuff if you want, but it's not gonna lead anywhere. These are also very straightforward. So if you notice, I do not have a second example for this. I mean, I do because it's this over here. I also have all those practice problems, but I just meant for today's lesson. All right, questions on any of those? Anything? Okay, when in doubt, make sure you check with your calculator. So if you do everything by hand, you get an answer, check with your calculator. Okay. If you can't figure out how to do an antiderivative and you get stuck, then just write the calculator answer down. Worst case is I'll give you a lower grade, but at least it's better than getting a 0 because you didn't do anything. All right. So if there are no questions on this, that is our lesson today. If you want to stick around, I'm gonna answer some questions first, and then. But if you want, you can get started on these. But I want to answer individual questions first, since I'm going to be bouncing around because some people might have questions on the quiz. What I want you to do for these questions right here is go to the website and just click the practice final right here. And I also got rid of problems on the practice final, so you should be happy about that. And you can just do, here's 514. I just screenshotted it from this, so it's the exact same problems. If you notice, I got rid of these right here because it's parametric and polar. For arc length, we're just going to worry about regular old functions that we've been doing rather than worrying about the parametric and polar. Okay? So if you can, I mean, you could screenshot this right here or just go to the website, but I'm going to help people with their quiz. Otherwise, you don't have to stick around, but I am going to go over this eventually, these problems, like today, after I answer all the questions first, though. I just don't want to keep people waiting. Okay? Sound good? All right. So who had the question about the quiz? I believe it was a quiz question.
That was me, I think.
All right. What time did you do?
Like first thing, so 9 or 10?
Okay.
Or, no, 1, my fault.
So that's this one here, right?
Yep.
All right. Which one did you want to go? Oh, you wanted to go over the second one, right? The partial fraction? All right, let's do it.
Wait up. Oh, 1 sec. Let me shut my window.
What's that?
I said, let me shut my window. It was super loud.
Oh, sorry.
Yeah.
All right. So let's paste this in. Okay. Okay. First thing that you want to do, and this is what I did in the red. First thing that you want to do is factor this out. And then once you factor it out, separate each of those factors into separate fractions. So if you factor out an x on those, you get this. So I separated them out. Forget the -1 and negative infinity. Those just carry over. I also took the 3 out because I always do that. You don't have to do that. Some people didn't. It doesn't matter. So are you good with step? Actually, what step are you confused now? What color?
It's after the A and B. After you find A and B. Basically.
All right.
So I was just wondering. Oh, sorry. Go ahead.
No, go ahead. Go ahead.
No, like, do we just? I don't even know how to explain it. You just go. You can.
Okay.
Yeah.
So after I found A and B, I plugged them in here.
Okay.
So then this 3 times the A is just going to end up being 1. So this ends up with being 1. The A is not 1, but 3 times 1/3 is 1. Same with the B. So this ends up just being 1 when this cancels, right? So then I did the antiderivative of 1 over x, which is right here with the ln x. Then I did the antiderivative of 1 over 3 minus x. The antiderivative of 1 over 3 minus x is actually negative ln of 3 minus x. A lot of people messed up the negative, but the inner derivative here is negative. So you have to divide by that inner derivative to get that. You could do use substitution as well. You get the same answer, but it's a lot easier to do. So that's how I got this blue part. Are you good with the blue?
Yeah, I just completely overthought it on the quiz. We're good.
Okay. Oh, so you're good with the rest of it then?
Basically, yeah.
Okay.
Or yeah, you can keep going because I'm sure people probably wanna.
Good idea.
Yeah.
So what I did is I had this ln minus an ln, and if you want, you could plug the -1 in. But what I did is I simplified using log properties. So you can rewrite that when you subtract. You can write it as a divide for one thing, this one whole thing like this. So now when you plug -1 in, you're going to get -1 over 4, but you're doing the absolute value. So it's just ln of 1/4. So that's this. Okay. Then when you plug in negative infinity, if you plug in negative infinity to this, the math gets really easy. Because if you plug negative infinity in, this 3 is meaningless. We're going to negative infinity. The 3 gets forgotten about. So now you end up with an x over negative x, which is just -1. but it's the absolute value, so it's positive. ln of 1 is 0. I mean, I just wrote ln of 1, but that's 0. So now you just have ln of 1/4 and you're done. Now, if you wanted, you could simplify this further because ln of 1/4 is ln to the 4 to the -1. You can bring the -1 in front. But then you can also turn the 4 into 2 squared. Again, you don't have to do this, and you can bring the 2 in front, so you get -2 ln 2. That's like the most simplified, but people usually forget the log, like simplifications of log properties, so I don't really grade those. So I would have accepted any of these as answers. That's why they're all the same color.
I know this wouldn't make sense, but on the exam, did I just read it wrong? Was it the integral from -1 to -infinity? Because I feel like those two were switched, weren't they?
No, that doesn't make any sense if you think about it. If you think about a number line, here's -1.
I must have wrote it down wrong.
Yeah, -infinity is that way. So you always go the lowest to the biggest. -infinity is smaller than -1. Because -infinity is getting negative. Just think -1 billion, trillion, zillion. You know what I mean? Compared to -1. You know.
Yeah, that makes sense. I think I just wrote it wrong on the exam.
Yeah, that happens. So, any other questions besides the practice final questions? Otherwise, we'll just go over the practice final questions if people want to stick around.
I have a question. So on actually that question, yesterday it was written as the integral from -infinity to -1. Like the 3 that's in front of it wasn't there.
Right, because here, let me show you. Where is it?
Okay.
If you go to the quiz, you can put the 3 in front. So there's a 3 there, but you can put it in front and make that a 1. I just always do that. We covered that in a previous class.
Okay, yeah.
To me, it makes it easier. I don't know why. It actually probably doesn't make it easier. It just makes it the same. But that's why that 3's I pulled that in front.
Okay, thanks.
Yeah. Mm-hmm. Any constant multiple, you can do that. So if it's a 3, you can do it. If it's an x like this top one here, you can't do it because the x is part of the dx. Like it's with respect to x, you need the x in there. The x is changing from 1 to 3. The 3 is always 3, so you can take it and put it in front. So, all right, what else? Anybody else?
But if you left it as a -ln to the 4th or ln 4, would that be wrong, or did you have to simplify it more?
The reason, if anyone did get an ln 4 and not the negative, is because they forgot this negative over here. If you forgot this negative, that's a minor calc error, so that's why you probably got a C on it if you messed that up. But it has to be negative. Oh wait, no, hold on. ln 4 would be wrong. That means you. How did you get ln 4? Did you get ln of 1/4 and you?
I didn't even get that far. It was just.
Oh, okay, sorry.
Yeah.
Yeah, if you got negative ln 4, then you're fine. Or if you got ln of 1/4, some people wrote that. That's fine too. Like any of those. Yeah, I feel like I'm not answering your question.
No, it's fine. I understand it now.
Okay. All right. Any other questions? Okay. Deleted. All right. We are going to go over these now. All right. So 511, this is what's going on in my brain when I see these kind of problems. So I advise like trying to think of it this way too, if you can, if it works for you. But it says find the area of the region enclosed by the curves, that and that. Now, it says the region's enclosed. It means you have to figure out where that region is. If you notice, they do not tell you the interval from A to B. So you need to figure out that interval. Now, how can you do that? What's the easiest way to do it? Someone help me out so I'm not the only one talking here.
The intersect.
The intersect. So use your calculator. Okay. So I would use your calculator on this to figure this out. So we got 7 minus, is it 2x squared? Yep. And then x squared plus 4. Now, if you wanted, you could solve this because it's quadratic. It's not too bad. Whoops, that's embarrassing. You can't really see anything. So we're going to do zoom 6. I try to make everything fit on zoom 6. So you should be able to, if I don't tell you the interval, then do zoom 6 and then you could be able to see it. Oh, look at that. That's amazing. Okay. And to figure out the intersect, you're going to use second calc 5. So second calc 5. Okay, enter, enter. Now I want the one on the left. I always start on the left. You can start with whichever one you want. Hit enter. I think it's just going to be -1. That's -1. Okay, now you can see it's symmetrical. So if you want to go, oh, I bet the other one's 1, just hit trace 1 and hit enter. And if you notice, it's the same. Oops, hold on. Hit trace 1. It's 5 for the blue. And then if you hit 1 for the red, it's also 5. Okay, or if you want, you can do second calc 5 and boom, 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 and get 1 as well. Okay, they're not always symmetrical. Actually, they are a lot of times, but don't assume they are because you know what happens when you assume. So it's -1 to 1 for this. Okay, so when you're setting up your integral, it's going to be integral, zoom in here, from -1 to 1 of whichever one's the one on top. Whoops. And the one on top, I believe, is the first one. That doesn't always happen, by the way. The blue is the one that's on top here, which is 7 minus 2x. But I don't always put the one that's the first one listed in the problem on top. So don't just assume that. So we're doing the integral of the top one. So this is our f. This is our g. X squared plus 4. Okay, we do need a parentheses around this whole thing. So you end up with something like that. Now, before you do any antiderivatives, I would definitely simplify this as much as possible. Okay, so like -2x squared minus x squared, like that would be -3x squared. Okay, 7 minus 4 is 3. Okay, just now we have a way easier antiderivative to work with. We don't have as many numbers, less likelihood of an error, that sort of thing. Okay, now let's do the antiderivative. If you remember, this symbol means antiderivative with respect to x, and then you plug in 1 and you plug in -1. That's what this means. It means take the antiderivative, plug in 1 and -1, and subtract. Okay, math's a language, like I say every other time we meet. That's what this means. Translate that to antiderivative, plug in the values and subtract. So we have the antiderivative to be -x cubed minus 3x. And we're integrating this from -1 to 1. Let me see. Is anyone even here? Okay, people are here. Sorry. Sometimes I talk to myself because everyone leaves. All right. This is equal to, so you plug in 1, you're going to end up with -1 minus 3 when you plug this in. Then you plug in -1. We have to subtract these. You plug in -1, and you end up with 1 plus 3. Okay, let me see here. Okay, I'm going to simplify these out. So this is going to be -4. And this is going to be 4. Wait, what did I? Hold on. Should have had a positive value. That's embarrassing. What did I do wrong?
Would it be -3x squared plus 3 because it's 7 minus 4, right?
Oh, that's so embarrassing. Who said that? Thank you. I appreciate that.
No problem.
This is the worst day of my life. Okay, awesome. Thank you. All right, so let's just get rid of all this. Sorry about that, everybody. I was testing you. I'm kidding. I just got it wrong. All right, so let's plug these values in again. All right, so we got -1 plus 3, right? Now I'm second guessing myself. Plug -1 and you get 1 minus 3. There we go. Now we're cooking with gas. All right, so now we have 2 minus -2, which is equal to 4. There we go. Is that right? Did anyone get that?
I solved it, but I didn't use -1 and 1. I had -1.0611, something like that. But my answer was 3.98. So I don't know.
Well, if you plug in 1, you're going to get -1 plus 3, which is what we have there. If you plug in and we're going to check on our calculator too. If you plug in -1, you end up with 1 because it's -1 cubed is -1. -1 is +1. Plug in -3, it's -3, which is what we have. Okay, I think this works. Let's check it on the calculator first. All right, and our y1 was first. So let's do this. Math 9, -1 to 1. Trace y1 minus alpha trace y2 x 4. Boom. Okay. Yeah, my second class is always better because I make all the mistakes on this one. No offense.
Well, I was just asking if my answer was 3.98. Is it wrong? Does it have to be 4?
I don't know how you got 3.98 if you plug in.
My intersection were 1.061 and -1.061.
I don't. Yeah, those intersections aren't right.
Okay.
You use your calculator to find the intersections because when we did it, it was 1.
That one. The 1.0.
But you use this value right here.
Yeah.
That's not the intersect though, because you look. So we're on the blue right now. If you go to the red for that same value, it's different. You see how the y's are different. You can't use that. You have the only way to get exact on these calculators is second calc 5.
Okay.
And then you get 1. If you just eyeball it, it's going to be wrong because your calculator doesn't know what you want. It's just doing what it's told, and it's told to just spit out. I don't even know why it's jumping like this. Actually, I do know because it's in Windows, and you can make it change. It changes by 0.75757575. Okay, if you had it change by something different, which I don't advise doing this, let's just say we had it changing by like 0.5. Oh, geez, never mind. Don't do that. This is embarrassing. I don't even know what's going on right now. All right, Zoom 6. Yeah, just don't eyeball it. Long story short, use the second calc 5. Okay, because you have to get the exact. Sorry about that. Yeah, that's why you got a value that was super close to it. It's super close to the 4, but yeah. This is sloppy. Are there any questions on this one? All right. Cool. All right, let's go to the second one here. The average value of 4 minus x squared from 0 to 3. So to find that average value, we would do the integral from 0 to 3 of that f of x. And then we just divide it by 3 minus 0. Okay, you can do this in your calculator, but again, I would expect you to show work on this. So first thing is you do the antiderivative of this. So I'll give you a second to do that. Then you plug in 3, plug in 0, divide by 3. Boom. All right. I think that's enough time for people, maybe. So we have the antiderivative of 4 is 4x. The antiderivative of x squared is x cubed over 3. Okay, and then we're dividing this all by 3. And we're integrating from 0 to 3. I like to pull the 1/3 out. So I'm going to do that. Pull the 1/3 out. And then we're integrating 4x. Change that to a fraction from 0 to 3. You plug in 3, you're going to get 12 minus 9. 3 cubed is 27 divided by 3 is 9. Now the cool thing about the 0 here is you plug 0 in, you get 0, so that makes it easy. Then you have 3 times 1/3, which is 1. Did anyone else get that?
Yeah, I did.
Awesome. Okay, we're still going to check it on our calculator, but I just want to see if anyone else got it. All right, here we go. Math 9, 0 to 3 of 4 minus x squared. Try not to forget the divided by 3 this time. Divided by 3, boom, 1. Cool, 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 cool. Put this right there just for fun. Questions on that one? Excuse me. All right, let's do 514. Holy cow, that's going to be a fun antiderivative. Maybe. All right, so we have L being equal to the integral from 0 to pi over 4. Okay. And we're in the square root of 1 plus the derivative. I didn't do the derivative of that. Let's do the derivative really quick. Okay, so the derivative of ln is going to be 1 over whatever's after it. So we have 1 over secant x times the derivative of secant x. The derivative of secant x is secant x tan x. It's one of those formulas you have to remember. Secant x cancels, so you just end up with tan squared x. That's nice. All right, that's actually equal to secant squared x, this 1 plus tan x squared. I'm going to act like nobody remembers that from the trig properties, so let's just do our calculator with this. So we're going to say calculator needed. Okay. Yeah, it's something like that, 0.881. I don't know if that's divisible by pi. I doubt it. No. Now, this should be the same thing as if you did the... Actually, I don't know if this is going to work. This might not work. 0.881 is the answer. I just want to see if this is actually equal to secant squared. It was. There you go. Doesn't matter. All right, so 0.881. 0.881. Sorry, I was just checking something else. All right, so L is equal to 0.881. 3 decimal places, por favor. And there we go. Questions on any of these?
Thanks for going over those problems again.
Oh yeah, dude, whatever you need.
Have a good one.
You too, thanks.
Yeah, thank you. Really appreciate it.
Oh yeah, no worries. And if anyone wants to stick around and start doing practice problems or whatever, I'm just going to be sitting here. So if you didn't like this lesson or you want to go over it again, my next lesson's at 2 as well. I should have invited everybody because I invited everyone to all of them, but you don't have to show up if you don't want.
I did send you an email yesterday about office hours tomorrow, and I don't know if you have a time specifically that would work best for you, but if you have anything open in the morning, that would be awesome.
Who's this? Oh yeah, Sophie. Yes. I did get your email. I just didn't put it in there. Yeah, you said 9 to noon or something like that, right?
Yeah, just anywhere in there.
I wonder if we should do the morning. I think what would be best. Yeah, I mean, let's just do. Yeah, we'll do 9. Let's do 9 to 9:30. If we need more time, we can, because the next one is going to be at for me is 10. So I'll send you the thing right now.
Awesome.
Right.
Thank you so much. I really appreciate it.
Oh yeah, no worries.
I'll see you
I
tomorrow.
mean, you didn't do as bad as I thought you were going to do, because you made it seem like you were going to you bombed the quiz.
I thought I bombed the quiz.
One thing too, I forgot to mention is if you bomb a certain section of the quiz, you only have to redo that section, so you don't have to even do the whole quiz over again. I should have said that to the other class.
Cool. Okay.
Yeah, it just saves you time. I don't know. Otherwise, we're just getting crazy with everything, and this class is crazy enough. I did the calculation. If you were actually in a regular school, like a high school, taking this, or not college, or not summer, you would have like 3 times more time to learn all this. So because people always go, high school doesn't prepare people for college. It's nothing. In college, they lecture to you and they don't really help you. High school, I feel because I'm a high school teacher, we help kids a lot. If parents get involved, and we have to try even harder, because parents, you can't get parents involved in college and stuff like that. So I try to give as much time as possible, because these classes aren't designed, in my opinion, to learn everything in 8 weeks. How can you learn everything in 8 weeks? I don't know. Yeah. To me, that's a little insane. So that's why I'm trying to be as flexible. That's why a final in 8 weeks is just normally you'd have 16 weeks. It's just crazy. So
yeah,
that's
I really appreciate that.